Hello everyone, this is the last part of the Az-204 Study Cram. So I hope you found a lot of added value from the previous videos and I hope you find added value from this one as well. Please like and subscribe if you enjoyed this series so far. So let's get into it. So we will start off by explaining Azure API Management, and as usual, before going through Azure API Management as an Azure product, I always like to take a step back and explain the fundamentals behind a specific product. So with that being said, I want to explain what is an API gateway, or what is the fundamentals behind an API gateway. So an API gateway is essentially a reverse proxy with API features. So by reverse proxy, I mean it's from the client to whatever API that you have. So it is nothing more than a reverse proxy with API features, which I will talk more about. API features include caching, throttling, etc. And I will go into them in greater details. The second fundamental characteristic of an API gateway is that it has a developer portal that allows users to interact with your APIs through that portal. So the fundamentals behind an API gateway product is essentially just a reverse proxy with specific API features. And by design, it should have a developer portal to interact with the APIs. With that being said, let me now go through Azure API Management as a product. So with Azure API Management, this is the standard architecture that you will place your API management into. So what you have here is you essentially have a client. In this case, it's a mobile application. It could be a browser, etc. And those clients access your backend APIs through the Azure API Management resource. So essentially, this Azure API Management resource is acting as a reverse proxy to the backend APIs, and you can add a lot of extra features on top of that API management resource. Again, features include caching, throttling, even checking for the presence of specific tokens, etc. So this is usually how you will see Azure API Management in a standard architecture. So it's essentially a reverse proxy that interfaces with your clients. So your clients in this case do not actually access the backend APIs directly. They actually access the gateway itself. In this case, it's the Azure API Management product. And if I go through a quick demo on the portal, in this case, I created an API management service, and you have this standard view. The most important thing is the APIs section, where underneath it, if I go to APIs, this is where I define my backend APIs. Okay, so if I click Add API in this case, I can define my backend APIs through multiple different ways. I can simply do that manually by typing the actual HTTP endpoint, or I can upload an OpenAPI specification, which is actually the recommended way if you have a lot of APIs. Or you can simply onboard backend APIs from Azure resources. For example, if your backend APIs are in Azure App Service, you can put that as a backend. If it's a function app, it's the same thing, logic app, etc. So in this case, I've already created an API called Demo Conference API, and this is actually given from the Microsoft official documentation. So if I go through this Demo Conference API, I can see a bunch of different backend APIs defined. Okay, so for example, if I go to this Get Sessions API call, okay, I can actually make API calls to this session, to this API, but what the users access is actually my API management endpoint. And then my API management endpoint will make this HTTP call to this backend. Okay, so in this case, if I go to the test tab, I can see this is the actual request URL that my client should call. Okay, this is not directly calling this API. It's calling, again, the Azure API Management resource, which then calls this Get Sessions API. Okay, so if I copy this request URL and I actually test it out in Postman, and if I click send in this case, so this is telling me that access is denied to this specific API endpoint. And the reason for that is because whenever you onboard an API to Azure API Management, in order to effectively access it, you need to provide what is known as a subscription key. Okay, so this is a nice thing about API management. By default, it actually protects your backend APIs through subscription keys. So I cannot access this API unless I have a subscription key. I will go through API keys in a greater details later on, but essentially you can see under this test tab, you can actually easily test your APIs from this blade right here without using something like Postman. And the nice thing is that it actually auto-populates the subscription key in this case. So if I click send, I should expect to get back some result from this API. And as you can see, this actually worked. So you have a lot of different things that you can do under this blade, but I will get back to it in a bit. Next, you have something called products. And products is essentially a way to group APIs together. So that's all it is. So you essentially group certain APIs together that then forms a product. Okay. And the nice thing about grouping APIs together to form a product is that you can apply specific policies and subscriptions to a specific product, which has a lot of APIs underneath them. Okay. So with that being said, let me now go through what is known as subscriptions. So in this case, I've created a couple of different products. You have this one, for example, created by default. So if I go to this test product, I can go through the APIs section and I can see which APIs are defined underneath this product. In this case, I only have one API, which is the one that I demonstrated. And the nice thing about this is I can actually add subscribers to this APIs. Okay, so by subscribers, I mean you add specific keys that you give to subscribers, which that they can or they should actually use in order to access your APIs. Okay, so the nice thing about having products is that you can create subscriptions, different access control policies, and different policies. Now, with that being said, as you can see here, the access control can be applied to administrators. So in this case, it's myself, the person who created this Azure API Management resource, or it can be developers. And developers are essentially the users who are actually creating those APIs. Again, they're called developers. Guests are the ones interacting with your APIs. So they're not the ones who are administrating this Azure API Management resource. They're not the developers that are actually creating the APIs. They are the people who are essentially interacting with your APIs. Those are known as guests. And again, you can create specific access control policies to limit specific APIs, maybe to just developers, admins, etc. And going back to this designer blade and going back to the same API get sessions, as mentioned, the beauty about having an Azure API Management resource is that, again, it's a reverse proxy. But the nice thing is that you can apply extra features to this reverse proxy. And those extra features can be caching, they can be throttling, etc. So what I want to show you here is how you can add a throttling policy, meaning you want to limit how many times users access this API in a specific time frame. So as you can see, we have the inbound processing, we have the backend processing, and we have the outbound processing. So the inbound processing is essentially from the client to your Azure API Management resource. Backend is from your Azure API Management resource to the backend. And outbound is essentially the response before it is sent to the client. So you can manipulate certain stuff based on the position per se of the API. So in this case, I actually added a throttling policy to the inbound processing rules. And essentially, this is just an XML. And again, you can actually add them through those snippets, so you don't have to actually type it manually. So in this case, as you can see, I added this rate limiting policy. So essentially, this is telling me that I can only call this API for 3 times before it returns back a 429 throttling error. Okay, so if I click discard because I already created that, and if I actually test this policy, if I go here and I click send, let's click send again, let's do that again, and let's do that again. As you can see, now I'm getting 429 too many requests. And again, this is one of the major benefits of using Azure API Management, because not only it's a reverse proxy providing more security, meaning that your users don't actually access the APIs themselves. The nice thing about this is you can create those extra API features or extra API policies such as throttling, which is super important. And believe it or not, it's a bit tricky to implement using code. Now, the last thing I want to go through is actually the developer portal. And when you go to the developer portal and under developer portal overview, you can essentially go through this developer portal that users use to interact with your APIs. Okay, so in this case, once I go through that, I actually get a designer blade where I can actually easily design my or customize my Azure API Management developer portal. Okay, so essentially you can customize the sign up page, the Explore API page, you can change those APIs, etc. But in this case, once you actually make all of those changes, you go back to the portal and then you essentially publish those changes. Okay, so once you do all of those changes under that designer blade or this customization blade, you can essentially publish this API. And once the Azure API Management Developer Portal is actually published, you can actually navigate through it as a user right now. So not as an admin who's designing the API Management resource. And if I navigate to this URL that I copied in a private browser so that I'm not actually an admin, this is actually what it looks like to guests. So guests can essentially sign up, they can go to the APIs section, they can test our APIs, again, provided that they're actually subscribed to the API and can actually provide the subscription key. So this is essentially a portal that allows guests to interact with your APIs, and any Azure API management resource or any API gateway resource should provide this functionality out of the box, and Azure is one of them. So with that being said, after all of that discussion, what is Azure API Management? So it's essentially an API gateway service on Azure that is serverless. And by serverless, I mean you don't have to configure any compute. Everything is done automatically with regards to the compute power. And after all that discussion, what is Azure API Management? So firstly, Azure API Management is an API gateway service on Azure that is serverless. With serverless, again, what I mean is that you don't actually think about servers at all. Second is that or the benefits of using Azure API Management is that it provides capabilities like auto-scale, monitoring, subscriptions and all of that, that you might not get into a standard API gateway product. And with using Azure API Management, there are a lot of different pricing tiers, and this can get confusing sometimes. So as you can see, this is a slide that goes through every single pricing tier, from consumption to developer to basic to standard and to premium. The simplest way to think about this is that premium is essentially the only pricing tier that allows you to place your Azure API Management into a virtual network. And sometimes that becomes useful, especially if you are interfacing with your on-premises APIs, especially if you want to segregate your APIs from, let's say, internal APIs to external APIs. You need virtual integration, virtual network integration in this case. The other interesting one is actually the consumption tier, where you essentially don't get most of the features. Like, for example, the developer portal is not included. But the nice thing about this is that it's a consumption tier, and it's super cheap, and it's based on how many times you actually use the API management resource. And a lot of customers actually prefer this approach. But again, the caveat is that you don't get most of the features that you get with other pricing tiers. Next, let's talk about Azure Eventing and Messaging Services. And as usual, before going through the actual products, I want to explain the fundamentals that will help you grasp the concept behind creating those products. So with that being said, I just want to emphasize that I created a super detailed video on eventing and messaging and all the eventing and messaging services on Azure, which I will link at the top. And again, I would highly recommend viewing this video if you want to get more confidence in this space. But I will essentially summarize most of the things I have discussed. So before, again, starting with the actual eventing and messaging services products on Azure, I want to start by explaining some fundamentals, starting by the difference between an event and a message. And before I explain what the difference between an event and a message is, I want to explain why this thing actually exists. Okay, so in the past, the way for two services to communicate with each other, and by two services, I can mean two web servers, two microservices, two function apps, two Azure app services, whatever they are, the standard way of communication between them is simply through request response. So the server sends a HTTP request and then would expect a response back from the other server. Okay. After that, eventing and messaging was introduced, and essentially a different way of communicating between services. Okay. So the first way is by using events. And by events, you essentially have the sender emit an event to a specific entity, and then you would have a receiver receive that event from that entity. Okay, so the nice thing about this is that they are decoupling between the services. So this is the major benefit behind using eventing and messaging, is that there is some decoupling that happens, amongst other major benefits that I actually go through into greater details in the video I have linked previously. But essentially, events are data that a service emits with no concern of receipt. Okay, so the sender just emits that event and has no expectation on who is processing that event or whether that event is actually processed. And that's actually different from messages, because messages, data that a service emits and expects a confirmation of message processing. So two very different things. When you emit a message, you would expect and you would actually request a confirmation of message processing. Otherwise, you will re-emit this message again. So those are the key differences between an event and a message. And next, I want to talk about the difference between topics and queues. So a queue is essentially a one-to-one between the sender and a receiver. Okay, so the sender sends a message or an event, and only one receiver receives that message or event. Topic is different, where you have one to many between senders and receivers. So a sender can emit an event or a message. You can have multiple receivers of that same event or message. So this is the key difference between topics and queue. And the first service I want to talk about on Azure is actually Azure Event Grid. And Azure Event Grid is essentially an event routing service that relies on a push model. Okay, so essentially what it is that you would have specific senders emitting events to Azure Event Grid, and Azure Event Grid will route those events to subscribers. Those subscribers can be Azure Function apps, web apps, standard web servers, whatever they are, okay? And this is typically used for near real-time scenarios because it's actually the only service on Azure that relies on a push model, okay? This is different from other services which rely on pull model, okay? So with pull model, you essentially have the consumer pulling events or messages from the entity, in this case Event Grid, or you can have a push model like Event Grid where you essentially have the entity pushing those events or messages to the endpoints. And if I go through a quick standard architecture of Azure Event Grid, you can essentially see that you have an Event Grid topic that you have specific senders emit events to. Okay, so in this case, I have an Azure Function app and I have a standard application web server sending events to this Azure Event Grid topic. And then that Event Grid topic will actually route or push those events to Event Grid subscribers. In this case, it's an Azure Function app and an Azure Web app. And if I go through the portal very quickly, you can see that I've created a demo-topic Event Grid topic resource. Okay, and if I go through that, actually I get the overview page. And the most important thing that you should know is that there are things such as access keys, which you need to use in order to emit events to this Event Grid topic. On the other hand, you need to also create Event Grid subscriptions. So those are like two different resources. And if I go through the demo of creating an Event Grid subscription, I can see that you can choose many different topic types in this case. Okay, so you can see you have Event Grid topics and you have a bunch of other topic types. And you might wonder, why is that the case? And the reason why that is the case is because on Azure, there are many built-in events that you can tap into. Okay, so with Azure Event Grid topics, those are usually custom events that you emit, for example, from a function app or from a web server, whatever they are. Those are actually custom events that you write. But on the other hand, you can actually rely on built-in events on Azure that you can rely on to push them to specific endpoints. Okay, so in this case, if I choose the Azure subscriptions example, and if I choose actually the specific subscription, I can see that I get those default event types that I can actually listen to. Okay. So in this case, if I actually go to the endpoint, and let's say I define an Azure function resource, this Azure function resource will actually get specific events, which is from the Azure subscription. Okay, so anytime those events actually happen, the Event Grid resource will actually push those events to Azure function, and then Azure function will actually process those events and action on them. But in this case, I want to actually choose an Event Grid topic because I want a custom event that I will actually emit from my applications. Okay, so in this case, if I choose the subscription and the resource group, and then I would actually find the demo topic, Event Grid topic that I actually created previously. Okay, so now the question is, how do we send events to this Event Grid topic? And this is a very simple code example that shows you exactly how to do that. Again, this is not a coding course, but sometimes when you see actually this, when you see this in action, it helps grasp the concepts much better. So the first thing you have to do is essentially define the topic key. Again, you need this key in order to send events to a specific Event Grid topic. And then you would obviously need to specify the topic endpoint, which you get from the Azure portal. And as you can see in this case, I'm simply emitting this event. And once I emit this event, I would expect the Azure Event Grid resource to push those events to the Azure Function App resource, which I configured as a subscriber. Okay. Next, I will go through Azure Event Hub. And Azure Event Hub is simply a data streaming service that streams events to consumers, and it is capable of handling millions of events. This will make much more sense if I explain it in a diagram. So as you can see, this is the typical diagram that you see with Azure Event Grid. So you essentially have sources or event emitters that emit events to an Azure Event Hub resource. And then you would have this Azure Event resource streaming those events to consumers. Okay, so think of it like a YouTube stream, where you essentially have a video that is streamed to multiple consumers. Okay, so in this case, we would have consumers relying on pull model. So consumers essentially in this case continuously pull events from Azure Event Grid so they can process them and then do certain actions. Okay, and the nice thing about this is Azure Event Hub is actually capable of handling millions of messages. Okay, so it is actually very useful in big data streaming services. Okay, for example, let's say you have a bunch of IoT devices emitting data. You can actually emit those data to a centralized resource like Azure Event Hub, which actually then streams those events to different consumers that can then action on those events. Okay, and the reason why Azure Event Hub is actually useful is because, again, it can handle millions of messages. Your consumers might not be able to handle those influx of data. So that's why you need a buffer in between. In this case, it's the Azure Event Hub. And if I want to go through the resource hierarchy in Azure Event Hub, which I find very useful to explain, otherwise it gets a bit confusing, you essentially have the Azure Event Hub namespace, which is actually the Azure Event Hub resource that you create on the portal. Okay. And then underneath that, you have several different event hubs that you can create. Think of those event hubs as essentially topics. So your event emitters actually emit events to specific event hubs under an Azure Event Hub resource. And then you would have consumers listening to events from specific event hubs. And if I go through the portal very quickly, I have this Event Hub namespace resource. And underneath it, I can create different event hubs. In this case, this is the event hub that I've created underneath this namespace. And essentially here you have some of important thing that you need to take into consideration is this shared access policy, which you should actually use in order to emit events to this Event Hub instance so that you can have consumers consume events from it. And again, if I want to go through a quick code example of how someone would process events from an Azure Event Hub, this is typically the coding structure with a Node.js application. So essentially you define a connection string, and then you would specify the Event Hub name itself. And then the consumer group, in this case, there's a default one. Again, I go through these in much greater details in the other video that I've linked above. And then here the storage connection string, and then the actual container name. And then here you can see that this is actually the a function that allows you to process the events that are being sent to Azure Event Hub. In this case, I'm simply just logging the events that I am receiving from Event Hub, but in the real world, you would probably do some extra processing on those events that you receive. Next, I will go through Azure Service Bus. And Azure Service Bus is the messaging service on Azure that supports both queues and topics. It's essentially the premium version of Azure Queue Storage with a lot of extra features that we'll go through into greater detail in the next module. And this is the standard architecture that you would see with the Service Bus resource. In this case, it's a Service Bus queue. And as explained, this is a one-to-one example between this Azure Web App resource and Azure Function resource. So the Azure Web App resource emits a message to the Service Bus queue, which is then received by the Azure Function resource. Next, in this case, we have the Azure Service Bus topic. And again, you have, in this case, one sender and multiple receivers of the same message. And if I go through this Azure Service Bus resource, under entities, you can see there's queues and topics. So if I go to queues, for example, I can create a specific queue. And again, you would use this queue to actually send messages to in order for the receiver to get that message. So if I go to this test-queue, I can see there's a specific queue URL that I would need to use in order to emit messages to. Okay, and then I would have to expect a receiver to receive this message and confirm processing of this message. If I go back to Service Bus and if I go to topics, in this case, I can see that I have a test-topic defined. And the difference between topics and queues is that in this case, you have to define a specific subscriptions. Okay, so if I click add subscription in this case, all this is essentially just a name amongst different settings that you can configure. Okay, so in this case, I have a subscription called endpoint 1. And this will make more sense in a code example, which I will show in a bit. As you can see, this is a code example that you essentially use to process messages on a topic. Okay, so in this case, as a receiver, you would define the connection string of the Azure Service Bus resource. You would define the topic name that you're actually consuming messages from, and you would have to define the subscription name that we have just created. Okay, then after that you would receive the message. In this case, all I'm doing is simply just logging the messages that I receive. But again, in the real world, you would probably do some processing on that message. Last but not least, I will quickly skim through Azure Queue Storage, which is essentially the same as Azure Service Bus Queue, but the difference is that Service Bus Queue is essentially a premium version of Azure Queue Storage. So again, it is a messaging service on Azure that supports queues, and you would use Azure Queue Storage if you have very high storage requirements, and it actually supports more storage requirements than Azure Service Bus Queue. Now, you would use Azure Service Bus for advanced features like first in, first out of the messages. Okay, and I go through this into greater details into the video I linked. Other features that you can actually take advantage of when it comes to Service Bus is duplicate detection. This is something you don't have actually in Azure Queue Storage, and it allows you to use other advanced protocols specifically for messaging like AMQP rather than just using HTTPS in the case of Azure Queue Storage. And the benefits behind using this protocol, for example, is that it guarantees persistence of the messages. So it guarantees the delivery of the messages because it keeps on persisting, sending those messages.